So, already the question is, what are polynomials? Does anybody know? What'd you say? Something with what? That's trinomial. Multiple terms. I'm gonna actually, you know how you have the little every square is a rectangle, but every rectangle is not a square kind of thing. So that's kind of the thought process with polynomials. Poly means more than one, right? Many. A polynomial is any algebraic expression with one or more terms. Okay. So a quadratic is a polynomial, but every polynomial is not a quadratic, right?
Right.
Okay. So we're talking about multiple terms. All right. So a couple things about polynomials before we start. To classify as a polynomial, we have real number coefficients. What's a coefficient? A number where? In front of the variable. It has real number coefficients, and all the exponents on the variable are positive whole numbers. So before we get into adding and subtracting, we also need to talk about a couple of things. Like this. Not like her. Hi. What does this mean?
I don't care.
Okay, like terms. So Isis said like terms have the same variable. That is correct. That is half of what it means to be a like term. What is the other half of what it means to be a like term?
Same exponent. Same exponent.
Same exponent. You're exactly right.
You have 2 minutes left.
Same variable, same exponent. Give me an example of two like terms.
2x squared, 2x squared.
What?
2x squared, not 5x.
2x squared, 5x squared. Give me two more.
7x to the third.
I heard 3x.
4.
So that's 7x squared.
Uh-huh.
Is that
And
adding?
7x4.
And 7x4.
Me and 7 would.
We're going to be adding and subtracting that, but I want you to be able to identify them first and make sure that you see. Okay? You sure? Okay, so the other thing you need to know is we can only add or subtract like terms. Only add, subtract when they are like terms. In other words, the ones that I wrote down here, I could add 2x squared and 5x squared. And I could add 3x to the fourth and 7x to the fourth, but I could not add 2x squared and 3x to the fourth. That I cannot add, okay? Because they are not like terms. Now, how do I add like terms? When you do that, you only combine, and I know that you think you know this now, but when we start mixing it with multiply, you start getting confused. You only combine the coefficients. Leave the exponent. Like, no, when you have like terms. I know. All right. So looking at these same two that y'all gave me a minute ago. Okay. If I were to add 2x squared and 5x squared, we said we only add the numbers in front, also known as the coefficients. So what is 2x squared plus 5x squared?
7x squared.
7x squared. What about 3x to the fourth minus 7x to the 4th.
Negative 4x squared. I mean, 4 to the 4th.
That is correct. Is anybody confused on adding like terms, combining like terms? Okay. Oh, yes, we will.
That's a whole nother section.
That's a whole nother.
Whole nother section.
No, we're not doing that today.
No, today we just add, subtract, multiply. All right. Now. C. Let's look at multiplying terms first, and then we'll add, subtract, and multiply the whole polynomial. All right, when I multiply terms, as opposed to adding terms, they do not have to be like terms. What? Does that look like a G?
It looks like terms.
It just looks like.
It's just not like it.
From like to me, I can see where it's coming from.
I mean, it definitely doesn't look like.
It doesn't look like a cursive C or a regular C.
Okay. Okay. Oh. Let's say I have 2x to the 3rd times 5x to the 2nd. Yeah. Well, think about your exponent properties. This is really multiplication, correct?
Yes.
And multiplication is, it starts with a C. Commutative, so 2 times 5 is, what is x to the 3rd times x to the 2nd? X to the 5th. So when I am multiplying, I multiply coefficients.
What? So when you're multiplying, you add the exponents.
Absolutely. And add exponents. Does that make sense? Okay.
That's the leader.
Yeah. Let's do adding first. All right, number 1. Adding polynomials. I have 3x to the 5th plus 6x to the 3rd minus 8x squared plus 2. To that I would like to add negative 4x to the 4th minus 6x to the 3rd plus 2x squared minus 7x.
Holy
Just
moly.
so that.
I'm done.
She really went in.
Might as well, right? All in.
Yep. Challenge.
Okay, so. Oh, this is as hard as adding is going to get, yes. I mean, it doesn't, addition and subtraction don't really get hard. All right. No, there's no equal sign yet, so no, we're not solving, we're just adding, we're just simplifying. All right. Yes, that's all we do. That's exactly what we do. Olivia's 100% right. It doesn't matter. I put these long polynomials up here so that you could see it really doesn't matter how big your polynomial is. All I'm doing at the end of the day is combining like terms. Start with your biggest and work your way down. Okay, I see a power of 5. I'm going to start with a... What? Oh, I'm sorry, y'all. Okay, 3x to the 5th is the only power of 5 that I see. I generally mark them out as I use them because it helps me as I go. Helps me keep track with what I've used and what I haven't. So now I would say, okay, I started with 5. Do you see any powers of 4?
Yes.
Sure I do. 4 to the 4th, there's not another one, so write it. Powers of 3. What is 6x cubed? It just cancels out. It's just 0x to the 3rd, which is 0. Negative 6 and positive 6.
Some people don't write it.
No, if it cancels out, don't write it.
Oh yeah, it's not one.
How about squares?
Yeah.
Yeah.
Negative 8x squared.
So it'd be negative 6x squared. Oh, wow.
Love that guy.
Negative, all right, so we did the squareds. Now we have just x. What do you have? Oh, and plus 2. Do I need to do any more examples of those?
Is
Thank
that
you.
it? That's all I have to do?
Yes. Absolutely. The only difference in subtraction. Right, so, Donovan, give me a polynomial. Randomly. Come on, come on, come on.
8x
8x
cubed.
cubed. That's a term. Give me a whole polynomial.
Oh, x squared
Plus x squared. Okay, come on.
minus 5x plus 1.
Minus. Justin, give me a polynomial.
Let's go with. Let's do like 16x to the third plus 2x squared minus 10x plus 2.
Because this is subtraction, I need to subtract everything that follows the minus sign. I would. Did you just double everything?
Let me do it. I got this thing.
I'm gonna do same. Change. And I am gonna change everything in the parentheses that follows the minus signs. Yes, that's exactly what I'm doing. I'm pretty much distributing the negative sign through. It makes it easier whenever you have such a large polynomial that follows. It helps you to kind of keep straight on what is what. So I'm going to make this negative 16x cubed, negative 2x squared, plus 10x minus 2. Now, I have an addition problem. Do you agree?
Yes.
Gather up your like terms. 8x cubed and negative 16x cubed is negative 8x cubed. This one's going to be easy since Justin simply doubled the first terms. X squared minus 2x squared. I've used that, I've used that, I've used that, I've used that. Negative 5x and 10x. I've used that. And 1 and negative 2.
Is that just
That's only because Justin doubled the first polynomial whenever he did it. So we took the polynomial, doubled it, and subtracted it from it, so that's why. It will not always do it, no. But you get the point. Do I need to do another subtraction?
No.
Speak now for everyone's piece.
Hold again.
Okay, moving forward. Multiplication then.
Come on.
I am going to take you back to distributing when we multiply. This is probably the most aggravating one. It's not hard, it's just involved. Let's say I have 2x squared plus 3x minus 5 times x squared minus x plus 4. If I need to multiply this, do y'all remember multiplying two binomials together?
Yes.
Foiling. So if you see something like this, you know that you cannot distribute that exponent through. Rather, you have to write it twice and FOIL it, right? Okay. When I teach FOIL, I don't teach it FOIL. I teach it as distribute because it helps you to understand when you get to a little bit bigger polynomials like this. What you are really doing when you FOIL is you are taking the first term and distributing it to everything in the second set of parentheses. And then you're taking the next one and you're distributing it through. So I'm going to take that same concept and I'm going to do this to this bigger polynomial. So I'm going to take 2x squared and I'm going to distribute it to everything here. So what is 2x squared times x squared?
2x to the
4. So we foil.
You're foiling on crack.
Take it 2.0.
Yeah, there you go, there you go. 2x squared times negative x is what?
Negative 2x.
Cube.
Why?
And then 2x squared times 4.
Oh, I see.
There's a 1, there's an imaginary 1. Sorry.
8x squared.
Now, I have distributed the first term through. And now I have to do the other two.
Is there a more
This is the most efficient way to do it, in my opinion. Really, what you're doing is you're just let's do the next term. 3x times x squared is
3.
and 3x times negative x is squared. Yes. Plus 12x. I'm done with the middle term. Do what? These get long. These do get long.
Minus 5x squared.
Minus 5x squared. Close. Plus 5x.
Minus.
Oh,
20.
Now gather up your like terms.
Woo! Yeah. Alright, so you start from greatest. 4.
Powers of 3. I got a 3 and a negative 2. Yes. How about powers of 2?
5.
8 and negative 3 is 5, and negative 5 is 0. All right, so x is 12 and 5 is 17.
Minus 20.
Minus 20. And I'm done.
Dang.
Now, I don't spend a long time on this because it's not really difficult. It's just really long. But let me show you this and I'll be done. You are going to encounter a couple different situations on your homework.
Couple different situations, guys.
Situations.
What if? That's good. You didn't say what if.
Did we title this special cases?
Oh, these situations.
No, it's just things to know about multiplication. All right. Let's say you got that. Whoever said hold on. Okay. Let's say instead of just two things multiplied together, let's say I'm asked to do something like expand this. What does the exponent of 3 tell me?
3 times.
3 times. So that means I've got 2x plus 3, 2x plus 3, and 2x plus 3. So my question is, how do I multiply 3 binomials together? Wing it. Okay.
You would,
Guys.
would you take those and do it to both of those and then?
So that's what everybody wants to do.
But can you
You want to bounce the 2x to everybody, but you can't do that. What you have to do,
Just do 2 and then do it.
you can never multiply more than 2 at a time, okay? So when you're multiplying,
So pull it out.
no more than 2 at a time. So, right, I would FOIL the first 2. Four x squared plus 6x plus 6x plus 9. Combine like terms.
This is regular FOIL, right?
Regular FOIL. I haven't kicked it up yet. 4x squared plus 12x plus 9. And now I do this 2x plus 3. Because I don't want to do more than 2 at a time. The biggest thing that I'm getting here is don't come to this first problem and go, okay, I'm just going to distribute this like this. I'm going to bounce it to both, and then I'm going to take this and bounce it to both. It doesn't work like that, okay? All right, so here, 4x squared times 2x.
8x.
Cubed. All right, remember, multiply coefficients, add exponents. How about here?
12x2.
And I'm done with the first term, so let's look at the second one. 12x times 2x squared. 12x times 3.
36x.
Just x.
Oh, 36.
Done with that term. And last but not least, that pretty little 9 that sits on the end. 9 times 2x and plus 27. Gather up your like terms.
8x.
It looks worse than it is, y'all, I promise.
Thanks, square, right?